A warm welcome to this session on Mark Locations for Components of Solar Photovoltaic Electrical System on Site. At the end of this session, you will be able to sketch a layout for fixing various components of solar photovoltaic system on site.
Tools and equipments required: 50 to 100 feet measuring tape, digital camera, record or logbook or diary, product manual for PCU or inverter, battery, etc. along with their dimensions, mounting angles, bolts and nuts. Plan exactly for locating the various components. Planning for locating various components needs a well-conducted assessment of the roof and also requires answers to the following questions. Is the roof suitable for installation of solar photovoltaic? Is the solar resource high enough? How much installed capacity could be fit on the roof? How much energy could the system deliver? A rooftop solar photovoltaic installation comprises of photovoltaic panels assembled in arrays, mounting frames to support the panels and secure them to the roof, wiring, inverters, and other components depending on the type of installation. The roof site must be able to accommodate all of these components, which requires examining the following aspects. Accessibility. The roof must be accessible to carry out installation and maintenance. It must be possible to lift the solar system components onto the roof and for personnel to physically access the site to install and maintain the system. Roof configuration. A roof plan can help quantify the roof area available for the PV power plant. The plan should be indicate the location, height and slope of the roof itself as well as any additional structures present on the roof. Identify any possible conflicts in usage of the roof, such as helipad or communication antenna, and contact relevant bodies to ascertain if any special permissions is required to use and alter use of the roof space. Roof materials and structure. For the existing buildings, first find out when the roof would need replacement. If a roof is nearing the end of its lifespan, it is more cost effective to install the rooftop photovoltaic system once the new roof is in place. It is also easier to integrate a system into the design of new roof. Aesthetics. Check that the solar photovoltaic module would not negatively affect the aesthetics of the building. From the street level, solar modules will be more visible on a sloped roof than on a flat roof. If they will be seen, find out if there are any local buildings restrictions preventing a visible rooftop solar photovoltaic installation. Roof leasing. If planning to lease the roof space to the owner of the rooftop photovoltaic system, consult a legal advisor who would be able to confirm whether that the type of arrangement is permissible. Electrical load. Obtain the current and expected electrical load of the building or facility. Should the load be comparable to or less than the electricity generated through solar photovoltaic? Plan a smaller system or plan to use the excess energy, either store the energy in batteries, send it to another building within the facility or feed it into the grid. Component dimensions and installation requirements suggested by manufacturers and hint about moving components to required places. Roughly 110 square feet or 10 square meter area is required for a 1 kilowatt installation. Accordingly, assess the site and recommend for more capacity. This will benefit the business as well as customer. Remember, inverter should be located in a room or shelter protected from sun and rain. Batteries should be kept in a room or shelter in a rack, and the room should be ventilated. If such space does not exist, suggest the customer to possibility of constructing shelters for equipments. For cable routing, do keep in mind that the inverter should be kept as close as possible to the DC combiner box, as DC side wire loss increases drastically with the length of the wire. Draw a rough sketch of how the cables will be routed and estimate the length of the wiring that may be required up to the switchboard. Sketch out a drawing to show locations of all components in the site. Light. The sun gives off light even on the cloudy days. Panels. PV cells on the panels turn the light into DC electricity. Inverter. The current flows into an inverter which converts it to AC electricity ready to use. The electricity. The current is fed through a meter and then into the consumer unit. Power supply to the house. Plug and switch on. The electricity that has been generated is ready for use. The grid. Any electricity that is not consumed is exported to the grid for others to use.
Recap. In this session, we have learnt how to sketch a layout for fixing various components of solar photovoltaic system on site. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you.